Duchenne is a profoundly disabling and fatal condition without exception. After the age of 13, there's a progressive downward decline. Individual measurements such as the 6-minute walk test may have small day-to-day variabilities, but the course of the disease is consistently downward in the teenage years.
Boys with DMD grow to be men with DMD, and they should not be forgotten here today in this discussion. There's been much focus and emphasis on walking as an endpoint in DMD, but walking is not an endpoint for a young man with DMD. Retaining upper limb strength is important for being able to eat, drive a wheelchair, type on a keyboard, and hold a job. These are the endpoints that matter.
My laboratory was the laboratory which identified the gene responsible for Duchenne dystrophy back in 1986. And we showed that major mutations at this 2.5 megabase locus were deletions in both the severe Duchenne form of dystrophy as well as the milder form of Becker muscular dystrophy. We showed in 1988 that protein was not being made in Duchenne biopsies published in the New England Journal of Medicine. Becker patients were shown to make an abnormal truncated protein of variable degrees of levels of the protein. This led us to propose, as Steve Wilton did, that potentially we should try to block the inclusion of exons and convert a Duchenne into a Becker by changing the reading frame and producing protein. Sarepta's eteplirsen is designed to block exon 51.
When a large treatment effect is observed, for example, significant improvement in a disease characterized by overall progression, an uncontrolled study can provide compelling data. There is agreement that eteplirsen does achieve its primary intended pharmacodynamic effect, that is, production of a truncated messenger RNA. There are also questions, and they've been raised today, about the utility of the information supplied by immunofluorescence techniques in comparison to Western blot. And these questions are going to be quite important today. In the case of accelerated approval, this finding can be made based on substantial evidence using a so-called unvalidated surrogate endpoint, believed reasonably likely to predict clinical benefit.
Study 201 was a 24-week study to evaluate dystrophin expression as a pharmacodynamic endpoint. After week 24, the placebo group was rolled over onto either 30 or 50 milligrams of eteplirsen. Study 202 extended the trial to further evaluate both continuing pharmacodynamic and efficacy endpoints and is ongoing to date. Data from all 12 of these patients were pooled to enable comparison to an external control over 4 years. Importantly, we are here today to seek approval based on clinical differences in walking ability in addition to dystrophin production.
The biomarker data are important for the committee to consider. As you've heard, if we believe that the biomarker data are reasonably likely to predict clinical benefit, it would open up the prospect of accelerated approval. There are 2 parts to this question. First, is there adequate evidence that eteplirsen produced dystrophin? And second, was the amount produced reasonably likely to predict clinical benefit?
Study 201, 202 showed increased dystrophin in all biopsied patients at week 24 that was sustained at later time points. The week 180 biopsy is considered the most important because samples were evaluated using methods, blinding, and controls developed in consultation with FDA. Our validated Western blot method, optimized to detect low levels of dystrophin, is arguably the first dystrophin Western blot to be truly quantitative. We have clearly demonstrated that sustained production of de novo dystrophin by all measures employed.
That convinced me that there is a functional significance of this level of dystrophin is that not only there is dystrophin at the sarcolemma, but there is restoration of protein of the dystrophin-associated complex.
Taken together, these data clearly demonstrate that eteplirsen is working as intended.
We came to very different conclusions.
There was 0.93% of normal dystrophin, as measured by Western blot, after long-term treatment with eteplirsen, with 17% of muscle fibers, with at least some detectable amount of dystrophin. Because of poorly matched controls, the proportion of the dystrophin produced by eteplirsen, as opposed to the dystrophin present at baseline, seems uncertain. Thus, it's not clear how much, or perhaps even whether, these values represent an increase over the dystrophin levels that were present at baseline.
Our studies in animal models also showed that much lower levels of dystrophin have a clear measurable impact on muscle function. And this is true whether we're expressing full-length dystrophin, Becker-like dystrophins, or even the microdystrophins that were developed in my laboratory. In fact, our studies indicate that any dystrophin expression has a beneficial effect on overall muscle function and physiology.
We pioneered PMOs for exon skipping and developed the eteplirsen sequence licensed to Sarepta. The dystrophin Western blot data presented by Sarepta demonstrates greater scientific rigor than is evident in any other published reports I have studied. Based on all our research and the data presented by Sarepta, it is evident that eteplirsen induces de novo dystrophin expression. I believe that it is reasonable to conclude that the increase in dystrophin is responsible for the clinical benefit reported in the patients.
For me, the best evidence was their Western blots, which showed 0.9%. We never see 0.9% in patient biopsy samples.
We know well from the earliest genetic DMD studies that the amount and quality of dystrophin production is the primary determinant of outcome in this disease. Dystrophin production linearly correlates with outcome. There has never been shown to be a threshold effect under which dystrophin level does not matter. Any increase in dystrophin is meaningful.
As was discussed by Dr. Farkas, it is not clear whether 17% constitutes an increase from baseline.
Dismissal of the immunofluorescence data seems to be skipping the critical point that these veterinary pathologists identified a clear difference between treated and untreated patients, 17% versus less than 1%.
In summary, at this time, we believe that the applicant's fourth biopsy data methods for the 201-202 study were the most quantitative and were reasonably adequate for determining the relative dystrophin levels for the purpose of their drug development program, with the caveat that there are some issues with the control sample that make it difficult to accurately calculate the change from baseline that could be caused by eteplirsen treatment.
One stated concern relates to the fact that the pre-treatment control tissues was exhausted, and thus controls from the Promovi pre-treatment patient biopsies were included in analysis of biopsy 4, challenging interpretation. It's important to note that 2 patient pre-treatment samples were included in both assessments of biopsies 1 through 3 and biopsies 4 by immunohistochemistry. These samples should serve as internal controls that allow for the validation of the new set of controls as typical of the treatment cohort. The findings are interpretable and clearly support induction of dystrophin. Given the level and distribution of induced dystrophin being observed, it's reasonable to expect that some positive fibers express as much as 5 to 12% of normal dystrophin, levels clearly predicted to impart some production of myofibers from contraction-induced damage.
Exon skipping works on very small groups of muscle cells.
We have clear data that even a single dystrophin-positive fiber protects adjacent fibers. So patchy or mosaic expression of dystrophin has a wider effect than just counting dystrophin-positive fibers.
I know well the difference between Duchenne and Becker muscular dystrophy, as I have cared for more than 150 boys and men with these disorders. And note that the fibers with dystrophin are larger and more frequent than any biopsy I've ever seen with revertant fibers. I believe these dystrophin fibers are driving the clinical effect. Furthermore, because Justin and Cole are so much stronger than I would have expected, if I met them for the first time today, I would have suggested they have muscle biopsies. When I consider their post-eteplirsen biopsies and their physical examinations, I would have reclassified them as having Becker muscular dystrophy. Thus, I do believe that dystrophin-positive fibers are a clear biomarker for strength and rescue of muscle.
36 prominent scientists and physician experts in Duchenne provided the FDA with a letter clarifying issues raised. Quoting from that letter, we conclude that there is strong evidence of induced dystrophin production upon prolonged eteplirsen exposure. The letter goes on to say, the findings of this trial are sufficiently robust to support the proposed mechanism of action of eteplirsen to provide a plausible explanation for the relative gain in function observed within the treatment group and serve to bolster confidence that there is a positive treatment effect.
Today, we saw data that eteplirsen-treated boys walk longer, walk farther, have more dystrophin on blotting, and on fluorescence. Moreover, this drug is safe. It seems prudent to recommend accelerated approval based on the data.
In summary, it is our position that the data you have seen confirm eteplirsen's mechanism of action and demonstrate that eteplirsen slows disease progression. Eteplirsen is the first therapeutic to unequivocally demonstrate an increase in dystrophin following treatment. The external control is a highly comparable and appropriate comparator to evaluate eteplirsen's clinical effect. Analysis of drisapersen placebo and synergy data confirm that our external control is representative of natural history. Eteplirsen slowed disease progression, demonstrating a clinically meaningful effect on the 6-minute walk test, and a dramatic difference in loss of ambulation. A critical question is how comparable this external control group is to the eteplirsen group. We see here that the eteplirsen cohort on the left is highly comparable on key prognostic factors to the primary external control group on the right. Looking first at the mean baseline age, we see that the groups are very similar. Mean baseline 6-minute walk test values are also highly comparable, with the groups differing by less than 10 meters. After year 1, the groups diverge, and by years 3 and 4, we see a nominally significant difference of 148 and 162 meters, demonstrating that eteplirsen slowed disease progression. This large magnitude of effect is equal to the length of nearly 2 football fields. Eteplirsen preserves ambulation longer than either the synergy databases or the external control.
So there's been this discussion about what page exon 51 patients walk to. So the best numbers that we have are 25% at age 16, but actually there's 15% of patients are walking till age 18, perhaps trying to show the way that we've seen the data, that there is not this very large difference in age at loss of ambulation between the treated patients and the natural history patients.
And I should point out that this is a rather limited data set. It only represents 3 patients, that when you talk about 25%, that only represents 3 patients.
The median age with current standards of care is between 11 and 13 years. And this is consistent across countries. Similar results were found in several US and EU countries, as well as in Japan.
Based on an assessment of all the physical performance measures, disease progression appeared to be similar for eteplirsen-treated patients and external controls. All eteplirsen patients who have maintained ambulation are still well within the age range in which exon 51 skippable patients appear commonly to walk.
I'd also like you to know that what we have observed in the eteplirsen-treated patients is very different from what I have seen in the natural history. I know this because every DMD boy who comes to Nationwide Children's Hospital for ongoing care undergoes a 6-minute walk test with the same physical therapist under the same condition as the eteplirsen trial, and we simply don't see similar results.
I am the lead therapist on the eteplirsen trial. The lead author on the publication from the Italian Natural History Study, Elena Mazzoni, is a member of our training team. This means that Elena and I present identical trainings on how to conduct functional outcome measures, including when to stop administering the test.
During the course of my career, I've diagnosed and cared for 250 boys with Duchenne muscular dystrophy, more than 20 of whom had exon 51 skippable mutations. Despite optimal care, none of those boys walk beyond 12 years of age. This clearly differs from the eteplirsen 201-202 experience, and where boys continued to walk for 3 to 4 years of treatment at ages greater than 12.
It does not appear possible to conclude that differences in physical performance between eteplirsen-treated patients and external controls resulted from an effect of eteplirsen, instead of from other differences and influences, both known and unknown, between the groups, both at baseline and during conduct of the study.
Duchenne Connect is the largest online registry, and in 2014, my group published a multivariate analysis looking at all 78 parameters collected and identified that the most strong correlate with age at loss of ambulation was by far the use of steroids. This is using a hard endpoint of age at loss of ambulation. There was a minor difference between daily deflazacort usage and daily prednisone.
The observations of DMD experts also guided FDA advice to the applicant that ambulation was particularly problematic endpoint in externally controlled trials in DMD. This is because, and this is a near quote from one of the publications and from talking to experts, this is because near the age at which patients lose ambulation, loss of walking is not a sudden hard endpoint.
I'm also here as the father of Dylan, age 15, living with Duchenne. He lost his ability to walk at age 13 and a half. Most boys that I know socially, and Dylan in particular, are very resistant to this transition and fight hard to push it back as long as possible. This is the case for Dylan. It makes age at loss of ambulation actually a rather hard endpoint. It makes it also an irreversible and highly undesirable endpoint with substantial consequences to his environment and care needs. I note as well, and this point has been brought up by several in the open public hearing and in the Sarepta presentation, that Dylan lost ambulation at 13 and a half and is therefore on the slightly more mild end of Duchenne, and that's supported by multiple natural history data. And yet, when he was 9, his 6-minute walk distance, as determined by being in a different clinical trial, would have compelled him not to be a part of this clinical trial. So the boys that are at the outlier end, those boys that are still walking at age 14, 15, 16, also tend to have better physical measurements at ages 7, 8, 9, and 10, the exact group that Sarepta was hoping to exclude from this. I'll also note that many of these opinions were shared in a letter drafted by 36 experts in Duchenne that actually do support that there is substantial evidence of efficacy for eteplirsen based on the clinical data and based on the reasonable comparison to multiple external data sets.
I would like to echo the opinions of my colleagues before me that loss of ambulation is truly a hard endpoint.
I have followed Justin since the age of 3 and treated with intermittent twice-weekly steroids. Based on all natural history that you and I have reviewed, he should have stopped walking by age 13. After recovery from a femur fracture, he is still walking.
I have observed unexpected stability in the one boy who I care for who mirrors the accumulated data of the eteplirsen boys. It is only in the past year, his 4th year on eteplirsen, that his walking has substantially weakened, especially in the past several months. These degenerative changes are coming much later than I expected.
Clinically, we rarely see a teenager remain stable over 6 months and never over 2 years. Yet to highlight just one subject in the 201 trial, 006, his 6-minute walk test has remained stable over 4 years with values of 355, 329, 359, 332 meters. He is now over 14 years old and still able to rise from the floor.
Our center was the lead enrolling site of the Miceli studies, and I think a comparison to this small study using historical cohort is relevant to the discussion today. The primary endpoint of the Miceli studies was ventilator-free survival. The secondary endpoint of overall survival was compared to an only 2% survival rate in the historical cohort. After 4 years of treatment, 44% or 7 of the 16 subjects were alive without assisted ventilation. In comparison, the clinical endpoint of functional ambulation is equally critically important endpoint in Duchenne. The importance of this type of binary endpoint is often emphasized by the agency and experts in the field. I think that the finding of 83% of eteplirsen study participants who are ambulant after 4 years of therapy compared to the finding of 44% survival should not be overlooked.
In other words, I would like to be able to prescribe this medication to other Duchenne boys who are amenable exon 51 skipping. The risk of harm appears to be minimal, and with close monitoring, I believe this is the best way to acquire additional information about this effective treatment.
As a physician, I want the option to prescribe eteplirsen. We cannot withhold a safe drug from even one boy who may benefit.
Although this is a small study, the effect is in fact well controlled given the constraints of pediatric rare disease research. And based on these observations of my patient in the study and in light of the findings today, I strongly believe eteplirsen meets the standard for substantial evidence of effectiveness and warrants approval in boys with Duchenne muscular dystrophy.
And while not a cure, the data indicates that the drug could slow disease progression. Many leaders in the Duchenne research and clinical communities have voiced enthusiastic support for eteplirsen. And as a science and evidence-based organization, their support carries great weight with us. We urge you to strongly consider all of the tools available to the FDA to allow the earliest possible access to eteplirsen. Thank you.
I can't really reconcile the difference between what the testimony that was given suggesting that boys are recovering abilities. Living with Duchenne, I don't understand how that's even possible.
Here we have an incredible advantage. In my time at the FDA, it's unprecedented to have basically all the patients here.
In the FDA Safety and Innovation Act of 2012, Congress instantiated in statute our accelerated approval regulations, and in doing so urged FDA to apply accelerated approval more broadly, particularly in rare diseases, while maintaining our standards. This is the standard for accelerated approval. So this would be a vote on whether or not the surrogate endpoint of dystrophin is reasonably likely to predict clinical benefit. All right. So you're talking about first whether question 1A, which you already discussed, whether or not dystrophin was increased. Now, reasonably likely, as you've already discussed, and I've mentioned in my opening remarks, there is no standard established, and for this condition, there is no threshold established because there's never been a drug to do this. So the question that you're being posed, if you follow me, is does the clinical experience in these trials with these patients lead you to believe that that increase is reasonably likely to predict a clinical benefit?
To what extent are we to incorporate into this question the testimony of the families, the boys and their families?
Because I would have two different answers to the questions. It's how to reconcile both in the same question here that I guess is the issue.
From my reading of the question, it would seem narrowly worded towards the actual statistical results.
Well, we are instructed, as people said, to take the views of the patient community into account. It's more on the benefit and the risk. The statutory standard is more or less as described there, but there is flexibility, and that's where we should take the views of the community into account.
I mean, would it be fair to suggest that you should take into account the totality of information in the briefing packet and what's been discussed today?
I think, Dr. Alexander, that that's a fair summation.
You heard testimony that might affect your views on the quality of the endpoints, on the importance of lack of blinding, and all kinds of stuff like that.
You could sort out whether or not the evidence provided from this study, with the information that you have at hand here from the patients, as well as what's provided by what you referred to as more objective results, rises to the standard that it creates substantial evidence of effectiveness. I want to reiterate all of these issues. I think it's very important to take into account the testimony you heard here today because you've heard half of the comparison. You heard from the patients in the 201-202 trial.
One of the things that you can do is try to reconcile what you've heard from the patients with the data that you've seen presented by the company. We're hearing patients are improving, doing things, next year that they didn't do last year, and you have to figure out if you can reconcile that with the actual hard data that you've been analyzing today.
Finally, I would note that much of the effort in evaluating a drug development program goes into avoiding a specific mistake, that is, erroneously approving a drug that is not effective. There often is little consideration of another error, which is failing to approve a drug that actually works. In devastating diseases, the consequences of this mistake can be extreme. But most of these consequences are borne by patients who traditionally have little say in how the standards are implemented.
We'll vote now. So once again, the question is, has the applicant provided substantial evidence from adequate and well-controlled studies that eteplirsen induces production of dystrophin to a level that is reasonably likely to predict clinical benefit?
Everyone has voted. The vote is now complete.
Thank you.
For the record, we have 5 yes, 8 no, 0 abstentions.
So we'll now go around and briefly state our name and vote into the record, as well as a brief rationale for why you voted as you did.
Richard Hoffman, I voted yes. By all the testing methods that were used, PCR, Western blot, immunofluorescence, I believe that there is proof that dystrophin was produced and that eteplirsen was responsible for it.
Nicole Gonzalez, I voted no. While I believe it is more likely than not that the drug does produce dystrophin, the clinical data as presented with the use of historical control was very problematic for me and does not convince me that whatever dystrophin is being produced is demonstrating a clear benefit.
Paul Rometti, and I hit the wrong button. We do see some difference. There was some evidence of improvement in endpoints.
So for the record, your vote is yes?
Yes.
Thank you.